Hello everybody, Mr. Shuck here. We're going to talk about section 1-2 in advanced algebra, evaluating and simplifying algebraic expressions. Okay, we're going to run through this fairly quickly. There are some terms you're going to want to write down. I will give you kind of an abbreviated, paraphrased version of the term. If you want to go into your textbook and find the bold printed terms in your section and copy them down in your notes, I think that would be a good idea as well. But to save time on the video, I'm going to kind of give you a paraphrased version of most of the terms. For example, we're going to start by talking about what a power is. Well, a power is a number, like the number 4, raised to an exponent, power, 4 to the 3rd power. This represents what a power is, 4 to the 3rd power. The 4, in this case, is considered what we call the base. The 3 is called the exponent. So instead of me writing down a verbal sentence definition for each one of those terms, I'm going to use a diagram like this. You may certainly go to your textbook and copy down a more formal definition if you choose, okay? And we know that that 4 to the 3rd power means 4 times 4 times 4. So a power is a number that's being multiplied by itself more than once, okay? All right, there are some other terms I want to talk about. What is a variable? Okay, you should know what a variable is. A variable is basically a letter. It's a variable, a letter, X, Y, P, S, whatever. It's a letter that represents another value. Okay, it represents some value. Okay, again, if you want a formal definition, go look in your textbook and copy that down. Something called a term. What is a term? A term comes in lots of different forms, but terms are separated by pluses and minuses. In other words, can a number be a term? Can the number 8 be a term? Absolutely. It's called a constant term. It's just a number. So you'd like, that's called a constant because it's just a number. Okay? Sometimes terms are just letters, a variable. The letter X is a term. I could combine them and make it 8X. That's also one term. That's not 2 terms. Yes, there's 2 things in there, but it's one term. Terms are separated by plus signs and minus signs. So what about something like this? What about 2xy squared? How many terms is that? That's a single term. There's no pluses and minuses. It's a product, right? But if I combine those 2 now, suppose I have 8x now plus 2xy squared. Now I've got 2 separate terms, okay? And together, this is called an expression. Okay, an expression doesn't have any equal signs in it, okay? Now, within terms, there's something called a coefficient. Coefficient. The coefficient is the number part, the number next to the letter. Again, I'm not copying down formal definitions and words. And if you want those, look at your textbook, copy them down. It would be a good idea to have a list of these things. I just think for the sake of time and interest on the video, I'm going to give you more of a paraphrased version, okay? All right. Well, what does all this stuff mean? What are we going to do with this? Well, one thing we are going to do, again, I'm videotaping this through Zoom, so I can't really save anything. I got to erase and start over, so hopefully you're hanging with me here. There's something called an order of operations. And if you're in advanced algebra, there's not a whole lot we need to talk about here. You should know what the order of operations is, and we know it as PEMDAS. P stands for parentheses, of course. Oops. I'll apologize for my spelling. You'll see that I'm not a very good speller here. exponents. Oops. Exponents. M stands for multiplying, D stands for divide, right? A is for adding, and S is for subtracting. And we want to do the simplifying or the combining of things in this order. You got to have a set of rules to live by, all right? I'll show you an example here. If we all did whatever we wanted to when we evaluated, we'd end up with all different answers, all right? So here's an example of how we do an order of operations, okay? So we would maybe call this a simplifying problem. Here's an example. 1 plus 7 squared parentheses 5 minus 3. We didn't have any order of operations to follow. We'd probably all come up with a whole bunch of different answers and we'd fight over which one's correct, right? But because we have an order of operations, we're going to start with the parentheses. We're going to take care of that first. 5 minus 3, well, that's 2. So we know that we're going to have a 2 there, right? Then we're going to look at my exponents and say, well, there's 1 7 squared. Let's take care of that. That's 1 plus 49 times 2. Now here's where it's really important. A lot of us are just going to want to go 1 plus 49 and add first. Well, that's not the order in which we want to do things. We want to do our multiplying and dividing first. So we're going to multiply 49 times 2 first to get 98. Then we can add them together and get a grand total of 99. So again, basic algebra. This is advanced algebra, so we're taking you through this fairly quickly, fairly slow. This should be a no-brainer, okay? Simplifying using order of operations. So you're going to have some problems that are going to have you do that, okay? All right. Well, what about evaluating and simplifying? What's the difference? Let's talk about evaluating. Here's a problem, a sample evaluating type of problem. Evaluating generally means you are going to substitute a value in for a variable and crank out an answer, okay? Notice there's no equal signs here. This is an expression, no equal signs. We're going to take this value of -5, plug it in for the y. So we're going to substitute that in. I like to use parentheses here for each one of my variables and plug in that number that's supposed to go in there. I like to see that worked out like that. And then I go through my order of operations, basically. I got to take care of this exponent first. And very common mistake here, -5 squared, if you use a calculator, it's going to say -25. And that's wrong. It should be a +25, right? -5 times -5 is positive. I can go ahead and multiply those things out and get a +55 there, plus the 34, or 35. I can go ahead and multiply this out and get a -150, plus the 55, plus the 35. And then you can crank all those together and you get a final answer of -61. So that's an example of an evaluating problem. Again, most of us know how to handle this. This is pretty simple stuff. We've done this before, okay? All right, not going to go too crazy here. Let's talk about simplifying. Simplifying basically means take what you have, combine what you can, and make it look nice and pretty. So let's take this, 14x minus 6y plus 5x plus 13y. When you simplify, what we're really trying to do is combine what we call like terms. Now, what the heck's a like term? Like term means you have the same variable raised to the same power or exponent. So when I look at my terms here, there's 4 terms. There's one there, one there, one there, and one there. There's 4 of them. 14x shares a variable with 5x. Same letter, x, same exponent on them. So I can combine the 14x plus the 5x, right? 14x plus 5x will give me 19x. They're like terms. The y is also shared with this y. They're both y's, and they're both, again, to the same power. So -6 plus 13 is going to be a positive 7y. And at this point, there's nothing else I can do. The x's are different than the y's. They're separate. They're different. I'm done. Okay? Okay? Just I'll keep that on the board here for now, and I'll do another example over here. Hopefully I can squeeze that in there so you can still see that. Let's do one that involves some grouping symbols. So if I ask you to simplify this, I got to take care of some parentheses. I got to distribute and get 2y plus 10, -3y plus 27, and negative times a negative becomes that positive. And now I look to combine my like terms. I got the 2y and a -3. That makes a -1y. Don't have to write the number 1 if I don't want to there. -y is the same as -1. Then I got plus 10 plus 27, and I get a plus 37. Again, nothing more I can do. One term has a letter in it, one term doesn't. I'm all done. Okay? So that's what we're going to be doing in today's lesson. A lot of very simple evaluating and simplifying of expressions. Okay? Be careful. Some of us maybe would have called this a -27. You know, you got to keep track of your negatives times negatives there and remember how to distribute and all that jazz, okay? I'm going to do one last example on solving. And what I know the topic today isn't solving, but that's where we're going to head to next. So what if I ask you instead now to solve something like this? What's different about this problem than the other two? This has an equation. It has an equal sign in it. And I know you've all had Algebra 1, so we know that you cut that equation in half and that this side has to equal this half, and what you do to one side you have to do to the other. And the plan is to get the letter of the variable by itself. So our first idea is, let's get this x over with this x. So I have a positive 8x. I'm going to take away 8. That makes 0, right? That's gone away. I got to take it away over here because those are the rules, right? Copy down what I have left over here. Let's take away 14 and take away 14. 2x equals 36, -36 there. To get the variable by itself, I undo the multiplying by dividing. Again, we're going to spend more time on this. This is just kind of a look ahead. So solving includes an equal sign, and you're coming up with an answer for that variable. And if we plug that back in our original, both sides should equal each other. We will also have some word problems from time to time. Those are all a little different. They're kind of fun, drive you nuts sometimes, but be prepared for a couple of word problems in this lesson as well.